So consider a body. This is a point A, and the body is at a height h above the ground. The kinetic energy and the total energy. Potential energy is mgh, and the total energy. Potential energy is mgh. Kinetic energy is 0, and the total energy is mgh then, because it's like you add it. What we are doing is, when you drop the body, you release it. The body is falling. So somewhere in between, when the body has been dropped by a distance of x, at this particular point, what is the potential energy? That is the question. So at point B, the potential energy will be mgh minus x, because this distance is h minus x. Potential energy is always the distance from the ground. Now at point B, I want to know what is the kinetic energy. So I use this formula, v square is u square plus 2as. Now when a ball is falling down, its initial velocity is 0. What is the velocity at this point? So initial velocity is 0, and the ball is dropping under gravity, so that is 2g, and the displacement that the ball has undergone is x. So v square is 2gx, and kinetic energy, which is half mv square, will be half into m into 2gx. So 2 and 2 get cancelled. Kinetic energy is mgx. So I write here mgx. So now what is the total energy? Total energy is again your kinetic plus potential. So kinetic is mgx, potential is mgh minus x. So that is mgx plus mgh minus mgx. Cancel, it is mgh. So that's the same that it was over here. And now if you allow the ball to fall ahead, and before the ball reaches the ground, just before it reaches the ground, that is point C. What is happening at point C? That is what we will see now. At point C, the potential energy is mg, and the distance from the ground is almost 0. So we take that as 0. And then what is the kinetic energy over here? So again the same question. If you can find velocity at this point, we can find the velocity at this point as well. Consider that the ball has started from 0 velocity and it has dropped a distance h. So v square is u square plus 2as. V square is 0 plus 2gh. So v square is 2gh, and kinetic energy is half mv square, that is half m2gh. 2 and 2 get cancelled. Kinetic energy is mgh. So that is mgh. Now 0 and mgh will add to mgh again. So this is our derivation, that mechanical energy, the total mechanical energy, is conserved at all points. It is constant at all points.